And so the next technique we're going to look at is what if you want to do trigonometric substitution using Maple. As before I said, I've already used u and v and other things, so what I'd like to do, just in case I want to use these generic variables like f and g and so forth, is I want to restart my worksheet. Okay? Now, suppose that you get to this point and you say, oh, wait a minute, I want to look back at problem 1a. Here's what you can do as well. You can hit this button right here, execute the entire worksheet, and everything you've set up until now will be repeated. Okay? And so, for this reason especially, it's really safer to put restart in the middle of the worksheet if you want something to start from scratch and use new variable names. Reuse the same variable names, that is. Okay. But whenever you do that, make sure that you import things you're going to need. So with student and with integration tools, they have to appear after restart each time. Okay? And just by copying and pasting them doesn't mean that they're actually in place, all of these commands. So I do have to hit enter on each one of those. Or I can re-execute the whole worksheet, and everything that I've set up until now is remembered in Maple's current storage. So let's say that now we want to look at a trig integral, and I'll just say trig int. I can name this part whatever I want. On the left hand side could be f, g. I'm going to say trig int, so it's a little more specific. And I want to set up something like, let's say 1 divided by the square root of 1 minus, let's say 2 times x squared. Or better yet, let's say 4x squared. Okay? And I'm going to integrate that with respect to x. Okay? So this sets up the integration problem for me, which if we were to look at a reference triangle for this particular problem, the substitution we would like to make is 2x is equal to the sine of some angle theta. Okay. Now I can use theta as the variable, or I could use something like x, y, or z as well. Maybe I'll use t. But here's what we have to do now. We have to rewrite this trig integral with a new variable. Okay? And so here's what we're going to do. We're going to write change var, which is the built-in feature for changing variables. Okay? And everywhere I saw x, I'm going to replace that with the sine of t divided by 2. And where am I going to do that? I'm going to do that in trig, if I can type, trig int. Okay? And now, instead of having an integration with respect to x, I also have to tell Maple that I'm integrating with respect to t from now on, after I've made the change of variables. Okay? And so as you can see, Maple's done some very nice things for us here. It's found every instance of x and replaced it with, well, sine of t over 2, and it's even simplified the 4. And furthermore, it found this dx, and it did the chain rule for us, because dx is negative cosine t dt, and the 1/2 came out as well. Okay? Now, here's what else we can do. I can look at the value of trig int, and I can look at the value of trig int 2, and I can check whether or not they're equal. Okay? In order to check whether or not they're equal, it might be better to look at something where we actually have limits of integration. So, I don't know, let's say that now we're going to go back and integrate from, let's see, how about negative 2 dot dot up to 2. Or, no, I'm going the wrong way with that. Let's try negative 1/2 up to positive 1/2. There we go. Okay. And now when I plug in my changed variables, it even changes the limits of integration for us. And now when I ask for the value of the first integral here, I get pi over 2. And when I ask for the value of this definite integral now, oh, okay, I also get pi over 2. Okay, and so clearly those values match. And you could do all sorts of other trigonometric integration problems in a very similar way by switching sine of t out with secant, cosine, etc. And whatever integration problem here with the limits of integration accordingly placed.